friends, MoNaCo here,
And Milks.
and we are coming to you with a very quick video on page 30.
Let's make this one real fast.
We're making up for the fact that our last one was a little long.
Yeah, but sorry. 4 basic types of reactions.
Page 30, 4 types.
Real quick.
First one, synthesis.
Means to make.
Right, there was a Poggle on this. You take two things, slam them together, you get one product.
Generic form is going to look like this.
An element or a compound plus another element or a compound, they come together, make a different third but single, only one product compound.
There's an example.
2 calciums plus 1 mole of oxygen, boom, makes 2 calcium oxide.
You want to take a second to code that or no?
Sure, I'll take a second to code this up. For example, you put an A above everything, that's the first element, so calcium, and a B over the different other type. And then you copy the arrows and pluses up, and you see that this code matches the generic type, so you know that it is a synthesis reaction.
Bien.
Bien, muy bien. Cool. Next one.
We might be able to get away without decoding these next ones. We'll see.
Decomposition.
Ooh, to break down.
Right, so you have typically one thing forming two or
It
more.
breaks
other.
up into its parts. So here we go.
Let's code this one up. So if I put an A above every time I see a P for phosphorus and a B over every O.
Bring up our arrows and our pluses.
Oh wow, look at that. Matches
Boom.
decomposition.
Beautiful. Signal replacement. One thing is going to switch out.
Swap.
Right, and one of the things you're looking for here is that lone C. You see that lone element?
Right.
That's where you're going to see it.
Now this is a little cool because you put a polyatomic ion in it.
I did.
And so, like balancing equations, we're going to keep the polyatomic ion
Together.
So I'm
So
going to put an A over all the silvers,
Okay. And then let's do NO3 as a B.
a B for the NO3,
Yep. And then C for the calcium, because hey, it starts with C anyways.
and we copy up our pluses and arrows.
And there you go.
Oh look, AB plus C makes CB plus A matches.
Bang. Next one, double replacement. I'm going to replace now 2 things.
Double
Notice-
swap.
Notice the D and the B are switching.
I hope you gave me some more polyatomic ions to do here.
I did. The reason why I switched specifically those D's and B's is remember when we made these things, the negatives or the positives are what's switching.
Put an A over every time I see sodium, a B every time I see the nitrate.
Oh, good. Calcium still sees it.
C for calcium.
I like that.
It's a coincidence, by the way.
I know.
Right. And then a D over the sulfates.
I'm just a geek, so I like that stuff.
Copy the pluses and the arrows up. AB plus CD makes CB plus AD.
Dude, double
Oh.
replacement.
But Mr. Milks, it's not a perfect match. What are you talking about? You said it has to be a perfect match.
Well-
AB plus CD, I got that, but this is CB plus AD, not AD plus CB.
Ooh. I really, because I wrote them in the wrong order.
You didn't, because
I know, because it doesn't.
addition
doesn't
is
matter.
cumulative. It doesn't
Yeah.
matter what order you add things, and you should be able to see, listen, just because they're out of place doesn't mean it didn't happen.
Right. I mean, AD plus CB is the same thing as CB plus AD.
That's why we say it's a commutative property of addition.
Seriously.
It's okay,
Yep.
Everything works out. So,
Perfect.
coding, not so tough.
Not
Remember
so
to keep
tough.
the polyatomic ions together as code,
Of course.
letter, and then compare back to your notes, and you're good.
So we're just going to have, there's a quick page of practice, and we'll be done with this one.
Sounds
Look
good.
at that. We're done with that video.
4 reactions,
No.
making up for borrowed time on the last video.
Yeah, here we go.
Thank you.